So in this presentation, we will be discussing about the celestial and various aspects related to the celestial objects. So let's start. Uh, First is the celestial sphere. Now, what is celestial sphere? If you consider Earth in the center and you keep on extending the surface of the Earth to all the sides, with the observer remaining at the center. Okay, so in that case, what you will get a celestial sphere. The other terms used for celestial sphere could be cosmic sphere, and in Sanskrit we called it as Brahmand. Okay, so here you can see this is the celestial sphere, and this is the axis. Okay, that is the showing north celestial pole and south celestial pole, and in this the earth remain in the center. We are just extending the boundaries of the earth towards heaven from all the sides. So we're just blowing it out and we are getting the celestial sphere. Now another thing which is important is celestial equator. See this is the celestial equator. So like what we were doing, we were extending the surface of the earth to all the sides. So same way, if you extend the equator in all the different directions, what you will get an imaginary great circle, that is the celestial equator. Now, celestial equator, this is celestial equator. It is dividing the celestial sphere into two halves. The upper one is the northern celestial hemisphere and the lower one is the southern celestial hemisphere. The next as important thing is ecliptic. So what is ecliptic? Ecliptic is the apparent path of the sun, and actually speaking, this is the actually the path of the earth in revolution around the sun. So ecliptic, if you see this picture, you can see between the ecliptic and the celestial equator, there is an angle. This angle is 23.5 degrees. Okay, so this angle is called as obliquity of the ecliptic, that is there between the ecliptic and the celestial equator. Now next important thing is zodiac band. See here, this is ecliptic. Okay, so 8 degree north and 8 degrees south of the ecliptic will create a band, that is a band of zodiac in which all the different planets are situated. Now, if you see the overall expanse of the ecliptic, that is circular band which is there, it is 360 degrees. So there are 12 zodiac signs. So each zodiac sign will get 30 degree, and each zodiac sign is named after a prominent constellation which is situated in it. Number of the constellations or nakshatras, they are 27. So if you see, each nakshatra is going to get 13 degree 20 minutes with 4 charans present in it. So if you see charan wise, then each charan will get 3 degrees 20 minutes. So every zodiac sign is going to have two 1 by 4 nakshatras. Okay, and remember, ecliptic is always in the center of the zodiac. So 8 degrees north and 8 degrees south, the band will be created, and that is called band of zodiac. All the planets are situated within this band, either 8 degree north or 8 degrees south of the ecliptic, which is not what ecliptic is the apparent path of the sun. Okay, so what is vernal equinox? First see that. When sun is moving from the this is the path of the sun. So when it is moving from the southern celestial hemisphere to the northern celestial hemisphere, it will reach a point where there is intersection of the celestial equator and the ecliptic. This point is called as vernal equinox. This is a point where the celestial equator is intersecting with the ecliptic. That is vernal equinox, which is the first point of Aries in Sayana system of astrology, and this coincides with 20th March. Okay. Likewise, when Sun crosses from northern celestial hemisphere to the southern celestial hemisphere, it reaches a point of intersection of the celestial equator with that of the ecliptic. This is called first point of Libra in Sayana system, or it is called autumn equinox. That is 23rd September. Now, what is the significance of autumn equinox or vernal equinox? See here, sun is crossing the equator. Okay, so duration of day and night will be equal at all the places on earth. Then celestial longitude and celestial latitude. Now, if you join the ecliptic North Pole, this is ecliptic North Pole, with that of the ecliptic South Pole by an arc, which is passing through a particular planet which you want to study. So this is the star is a planet, and you are crossing the northern ecliptic pole. There is an arc which is joining with the southern ecliptic pole. Okay. Now here this is the vernal equinox. So distance from the vernal equinox to the arc, which is crossing the ecliptic at right angle, is the Sayana longitude of the planet. So remember, this is the arc which is moving from north to the south ecliptic pole, and this is passing through the star. So wherever it crosses or touches the ecliptic, okay, consider this point. This is a point where it touches the ecliptic. So from vernal equinox to this point where this arc that is coming crossing through the star, it touches the ecliptic. This entire thing, this angular distance, this is called the longitude of the planet. Okay, and this angular distance from this point up till the star, okay, this angular distance, this is called the latitude of the planet. So remember, when we talk about latitudes, latitudes are never beyond 8 degrees north and south, uh, because if you see the zodiac band will be 8 degree north and 8 degrees south of the ecliptic. So that's why latitudes here will never be beyond 8 degrees north or south. Then another aspect is right session. A session, when we say, is a rising star, okay, and declination of the planet. So here you draw an arc which is connecting the uh, northern celestial pole and the southern celestial pole, that this is passing, this arc is there which is passing through the planet, okay, and it will cross the celestial equator vertically at some point. So here if you see, it is crossing it at a point P1. Okay, so what is the declination of the planet? Declination of the planet is the angular distance. Now this can be, depending upon the location of the planet, it can be towards north. If the planet is present towards the south, then declination can be towards the south. So this angular distance which is there between this P1, that is the point where the arc crosses the equator, and the star. Okay. So, declination of the planet will be the distance from P1 to P. This angular distance is the declination of the planet. And remember, here we are talking with reference to the celestial equator. This point is with reference to celestial equator. Okay, so from celestial equator, the point where the arc is intersecting, okay, so that is P1 to P, this will be the declination of the star, and right accession will be calculated with reference to the vernal equinox, from vernal equinox to this P1. Okay, when you move towards right, towards P1, this entire distance, this is the right accession. Okay, so at the vernal equinox, if you see, the right accession will be considered as 0. Okay, and you know the celestial sphere, it is 360 degrees. So in 24 hours. So that means 15 degrees per hour. What does it mean? It means that if you start from the 0 and move towards the right, you this is the first meridian. So between 0 to the first meridian, okay, there is this is 15 degrees, okay, and 15 degrees is equal to 1 hour of time. Okay, so what we said 360 degrees divided by 24 hours will give you 15 degrees per hour. Okay, so that each meridian that is there towards the right of the vernal equinox, if you move like this, okay, so this is first meridian, so this is uh, with reference to this is 15 degrees, and the time that has elapsed is 1 hour. So these meridians at the interval of 15 degrees, they are called as hour cycle. Then another concept is altitude and azimuth. So here you draw a great horizontal, this is the horizontal circle which is there on the horizontal plane, and the observer is at the center of this horizontal plane. Okay, and you know the head is always what we say as zenith, and on the opposite side, if you see this y, this will be the just corresponding to the uh, lower part, that is nadir. So you have to join the zenith with the nadir, okay, and then when you draw a arc, okay, which is passing uh, from zenith towards the nadir, but passing through the star, the arc is going to cut this horizontal circle at some point. The point is referred, says we consider this point as M. Okay, so here is the star, and this is the point where it cut the horizontal circle. So in that case, S and M will give you this arc S and M will give you the altitude of the planet. Okay, and from the northern side, if you see from north side to the horizontal great circle, when you come till M, this distance is azimuth. Okay, so from M to S, you're going to get altitude, and from north towards M, you will get azimuth. Okay, so when you measure azimuth, it can be unidirectional also, it can be bidirectional also. So what we were saying, from north, we are moving like this. Okay, we are moving like this. So suppose if the distance is over here, okay, so this will be 60 degree. So it can be like this, you move like this. Okay, this is unidirectional. The other approach is you may move from 0 to 180 degrees east, and from 0 to 180 degree west. Okay, so altitude of the sun at the sunrise will always be 0 degrees. Okay, whereas when it crosses the meridian plane or the vertical plane at noon, then it will be at the meridian cusp. So there are three systems of locating a planet that we have discussed so far. One is the coordinates, one is the ecliptic system, the other is the equatorial system, and then we have the alt azimuth system. So ecliptic system, this is the one that we discussed for getting the celestial longitude and latitude. This, always remember, is with reference to ecliptic. That's why it is called ecliptic system. The second system, which is for getting the declination and for right precession, this is with reference to celestial equator. See here, this is celestial equator. So this is with reference to celestial equator from vernal equinox till the point where the arc coming from the planet, it crosses the celestial equator. You will have right accession, and from this point onwards up till the star you have declination. In this case, it is with reference to ecliptic, okay, from vernal equinox to the point where the arc coming from the star crosses the ecliptic, that is the longitude, and from this point till the star, the arc angular distance what is there, that will be the latitude. So the third system is with reference to altitude and azimuth, wherein you have a horizontal circle, and observer is always at the center of the circle, and from zenith till nadir you are going to make an arc which is passing through the star. So wherever it touches the horizontal circle, so this arc from star till this point where it touches the horizontal circle, that will be altitude, and from north till this point, that will be the azimuth. So this way you can locate a star using these coordinate systems, uh, wherein three different approaches are being used. Then oblique accession. Now accession, you know, is a rising star. So oblique accession will give you the rising time of different zodiac signs at a specific location. Okay, and it is going to vary with the sign, it is going to vary with the latitude. If you see the equator, uh, a sign is there, suppose at the equator. So seventh from that sign also will take the same time to rise completely in the eastern horizon. So like if you start with Aries, then the seventh from that will be Libra. So they both will take same time to rise completely in the eastern horizon, but it is going to vary with the different latitudes. And what they say that what you observe in the southern latitude is just the opposite of what you observe in the northern latitudes. Okay. So generally, signs from Capricorn to Gemini, it takes lesser time to rise as the latitude increases, but signs from Cancer to Sagittarius take greater time with a successive increase in the latitude. Then Sayana system is followed by Western astrologers, and we know vernal equinox is the first point of the Aries, which is the point of intersection of the celestial equator with the ecliptic, and so where sun crosses from south to north, and this is the first point of the Aries and Sayana system. When we say Sayana, that means we are talking about Sa means with, and Ayana is for Ayanamsha. So that is with Ayanamsha. And here vernal equinox, we remember it's on 20th March, and what is interesting in this is that vernal equinox, this point is uh, not fixed, okay, and it is moving westward. So see, this is the ecliptic, and this is the ecliptic, and this is the equator. Okay, so every time there is a small shift with what we observe in the vernal equinox, it moves 50.29 second westward. So towards here is the east. So here is the west. So see, 1 year it's corresponding to V1. Second year it will be corresponding to V2. Third year it will be corresponding to V3. Okay. So this shift that we observe in the vernal equinox, wherein it is moving 50.29 second of the arc westward every year. This is known as precession of equinox. And all the zodiac sign that starts from the vernal equinox, this is known as movable or the tropical zodiac or the zodiac of signs. So remember, this is a system which is followed by Western astrologers. Okay. Now we come to the Niryana system. Now Niryana system is the one which is followed by Hindu astrologers. Now here the first point of the Aries is fixed with reference to a background star. So here the star which is chosen is a Spica star which is there in Chitra Nakshatra, and the 180 degree from this star is the first Niryana point of Aries. So Niryana means without an Ainamsha. That's why this name is given Niryana system. So here the zodiac start from the first point of the Aries in the Niryana system. That zodiac is known as fixed sidereal zodiac or zodiac of constellation. Okay, so it is a fixed point. It is not going to change like in case of the Sayana system. A very important thing is Ainamsha. So we know that in Niryana system there is a fixed initial point, and in Sayana system you have vernal equinox, and vernal equinox will keep on shifting. So whatever the difference between the fixed initial point of Niryana system and the vernal equinox of Sayana system, this difference is known as Ainamsha. Okay. And remember, the first point of Aries in Niryana system is always at an angle of 180 degree to the Chitra star. So that's why Ainamsha is also referred to as Chitra Paksha Ainamsha. Okay, because we are always with reference, we're talking in reference to the star, uh, uh, Spica star, which is there in the Chitra Nakshatra. Then planetary longitudes, they are measured from vernal equinox, and that give us the Sayana position. Okay, so if you know the Sayana position, then you apply the Ainamsha correction to it, and what you will get the Niryana longitudes. So this approach is generally used. You measure from vernal equinox, find out the planetary longitudes, and that is based on the Sayana position because vernal equinox is in the Sayana system. To this you add Ainamsha. Ainamsha is what? Ainamsha is the difference which is there between the fixed point of the Niryana system and the vernal equinox. So if you add Ainamsha to the vernal equinox, you are going to get Niryana longitudes. Thank you.